Okay, so another good tech-free question, tech-active I mean. So this is our parameter here that we're using, and x is our exponential random variable. So the mean of x is equal to this. The mean is equal to 1 on delta. Now it tells us down here that the mean is 4 years, which means that 4 is equal to 1 on delta, or delta is equal to 1 on 4. Now, we can take this fact and substitute it in to our equation here. So, if I want to determine the probability that the individual keeps their first car for between 3 and 5 years, it's really asking me to integrate between 3 and 5 for our function of a quarter e to the power of negative a quarter x dx. Now, I can go through and do this the manual way by, integrating this, which would be a quarter multiplied by e to the power of negative a quarter. When we integrate, remember this part comes down, so it would be minus a quarter on the bottom here, meaning this 4 would flick up to here. So now that's going to change into 1 on 4 times 4 on negative 1. They will cancel. I'm left with negative e, negative a quarter, 5 on 3 like that. Then I would substitute these into the equation by doing negative e to the power of negative 1 on 4 to the power of 5 minus negative e to the power of negative a quarter to the power of 3. So that's what I would be doing. But there is a faster way. So if I go here, options, calc, now I select the integral. Now I can just punch it straight in. So now I've got 1 on 4 e to the power of negative 1 on 4 I'm going to change that to a fraction to make sure weird things don't happen. 1 on 4 times in x. And that is between 3 and 5. Execute. Okay, so now we get our answer here. So here we go, is equal to 0.18586, which means that if I'm rounding this to 4 decimal places, it will become 0.1859. Or you could also say it's 18.59%. Okay, next part of this. 50% of individuals want to keep their cars for the most K years. Okay, so this time we're solving for K, determine the value of K. So what do we know? We know 50% of people want to keep their car from the time they get it to the time they sell it. Our function didn't change. So this is what we're solving. Now, if I take all of the integral stuff that I did above, you would see that we would end up with minus e to the power of minus 4x over, substituting k, substituting 0, 0.5 goes on this side again, is equal to minus e minus 1 on 4, k minus e minus 1 on 4, 0. This part on the end here is going to cancel out to be 1, minus a negative, we'll change that to a positive, so it's going to be plus 1, which is going to be equal to 0.5. Take this to the other side, it's going to become negative. So now I'll have 0.5 minus 1 will be minus 0.5. Now I can divide the other side by negative 1 to get rid of this as well. So this is what I've got left at the moment. Okay, now I can take e across. This part's going to become positive. So now I've got ln, we'll log with base e, 0.5 is equal to e to the power of, e's gone now, negative 1 on 4 k. So now I can take the negative across by dividing. Actually, I'll take the whole thing across. No, I'll take the negative first. I'll show you all the steps. 1 on 4k. Now I take the 4 up by multiplying. So that's going to make it minus 4 there. So k is equal to negative 4 ln 0.5. Now, yes, we did it. It took a lot longer than it should have, though. So where were the cheats? You could have used solven straight from this point here, or you could have used solven from here. So now on the Casio CG, it takes a little bit longer, but all we needed to do to get it to solve this for us is use my favorite button, solven. We want it to be equal to 0.5. Now I'm going to go across and change the value. So this time x is the thing getting substituted in, so I don't want to use x as the variable I'm solving for. I'm going to just pick an arbitrary one, alpha a. So now I'm going to tell the calculator, comma, solve for a. Close my bracket, bada bing, bada boom. Now this is going to take a bit longer than you're used to, but it will still give you the answer. So while it does that, I'm going to punch it into my calculator, what I got there. So negative 4 ln 0.5. And so k should be equal to 2.77. And we'll leave it there. 2 decimal places should be fine. This would eventually work, but it does take a long time. In your exams, I wouldn't always rely on doing this. It's an option, but really it takes about 5 minutes for it to solve itself.